Hello and good afternoon to all. If you have knowledge, let others light their candles in it. Starting the day with this Pearl of Wisdom by Margaret Fuller, a very warm welcome to all the delegates present here on the third day of Global Conference on Artificial Intelligence and Applications, GCAIA 2020, organized by University of Engineering and Management, Jaipur. My name is Professor Shatabdi Basu from Department of Computer Science and Engineering, and I will be your host for today's session. The aim of this conference is to promote dialogue between scientists, researchers, engineers, corporates, and scholar students to mitigate the gap between academia, industry, and governmental ethics. This motivation will be fostered through keynote speeches and oral presentations by eminent researchers in relevant fields. The platform of GCAIA will bring regional and international concerns for the discussions on recent advances in modern computational intelligence. The first corporate keynote speech of the day will be delivered by Dr. Sumant Kulkarni, Director and Head of AI for R&D Division, ZenSár Technologies. A doctorate in Information Technology from International Institute of Technology, Bangalore, Dr. Kulkarni has been a data science enthusiast for over 13 years. He has worked on building machine learning-based enterprise solutions for problems involving NLP and computer vision, recommender systems, and predictive systems. His research interests are in social network analytics, information retrieval, cognitive computing, information extraction, and computer vision. Dr. Kulkarni, we welcome you to GCAIA 2020, sir, and I request you to deliver your address on the evolution in need of enterprise AI. It's over to you, sir.
Thank you, Shatabdi. It's a great afternoon to meet you all guys, and it's a great forum. I hope that the last couple of days were joyful and had a lot of discussions on various progresses AI needs to go through. So because I have only 30 minutes, I'll immediately get into the keynote, and if there are any additional questions which I cannot answer probably at the end of this, I'm ready to take them through even emails or even on my LinkedIn, people can contact me. So I am sharing, just a minute. Please let me know whether it is visible.
Yes, sir, it is visible.
Yes, sir, it is perfectly visible.
Okay, great. So even though I gave a title which was very much aligned to this, I just tried to reframe this title. This is Evolution or Revolution of Enterprise AI During and After COVID-19. The idea here is that the evolution usually takes a longer period of time, but here what we are talking about is a faster way of changing things, and that's where probably we can even call it revolution. So this is about me, and Shatabdi has introduced me, so I would not talk about this part. These are the places where you can reach me, and I'm very active on social media, so we'll be able to get responses pretty quickly. Here I would, in this keyword, one is the research aspect, for which you guys have all met here to discuss your research ideas and explore things. But what I am also more focused on is the business aspect of research, right? Because post-COVID, post-Cold War, right, what has happened is the research areas are completely driven by business interests. Till Cold War existed, there was always funding for the research universities as well as larger defense areas. So they could do open-ended research to a very large extent. But slowly what's happened is that open-ended research funding has gone down, and the business value-based research is taking priority, and rightly so, because we ultimately want to derive value out of whatever research we are doing. Um, uh, so, and why we are now talking about the COVID, right? The COVID has brought out the vulnerabilities we had in our system. So we realized that redundancy is essential, highly essential for the current systems. For example, there were a lot of uh, employees who could not work for a while, and because of that, the services got shut. Then there were the people are not ready to actually use touch-based systems. People do not want to go and actually use, for example, the Aadhaar, where the fingerprint, you have to give a fingerprint. So people want touchless systems. People do not want to use ATM machines. They are very uncomfortable with it. Third thing is about people being remote and still want to actually access systems. These are the three major areas where we need to focus so that our research actually delivers these experiences. So I would not want to explain too much here. So we are a lab in ZenSár, and focus is on building IP for ZenSár, more than 40 patents, and we are hiring researchers and data scientists. And I need to talk about that if anybody is interested who have a decent experience, 6 to 10 years experience in research and data scientist, we are looking out. So that's something I need to do. I will do it as a part of our organization. So this is, we have had a 5 years of journey in terms of ZenSár AI lab. Have been pretty active in terms of patenting as well as research. We have been building quite a few IPs for ZenSár for showcasing cutting edge technology. We look at AI in three aspects. So the AI has a core research AI, which actually people work on with, but ultimately this has to yield into one of these two things: decision or experience AI. So the decision AI is about the backend where people take decisions whether something is a fraud or not, something has to be recommended or not, all those kind of things. Whereas experience AI can be like natural language generation, speech generation, and all those kind of things. So all three aspects actually come together and form the overall AI framework in terms of enterprise. So the enterprise has to care about all three things, because ultimately experience AI is always enabled by decision AI, and decision AI is enabled by research AI. Research AI directly can also influence experience, but this is one of the parts which is seen predominantly. So what has happened after we were hit by COVID, right? So there are three recovery areas. So what has happened is a lot of industries have been hit negatively, and some industries have been hit positively. So what it means is, so there are some industries like who actually manufacture masks and all, who actually are impacted positively, where they're getting their higher profits. For example, sanitizer manufacturers and all. Whereas there are a lot of other industries like vehicle manufacturing, be it cement, be it transport, be it airline, they have been hit negatively. So we in a industry look at it as a three region-based recovery. So initially, for first 2 to 10 months is an impact zone 1, where the recoveries are slow, as well as the impact is seen highly. So people will be panicked. So the industry would want to actually care more about saving their businesses. Nobody cares that much about growth in this case. But in impact zone 2 and 3, what happens is people start thinking about growth, and this is where the real research need comes into picture. So once again, the way we started looking at AI changes. So the manual to discovery of new threats and all modes of operation will get replaced by automated, because we know that people-dependent business running is not the only way of running business, because you need to create redundancies. So physical to touchless employee, client, and vendor engagement is another area. Centralized to distributed business management, that is something which is going to take place. Fixed to on-demand labor. So the labor, whatever we are looking at, whatever the paradigm today we are into, right, where we all are permanent employees, that slowly starts moving away from that to actually a kind of a on-demand kind of thing. Then bucketized, hyper-personalized experience. So it's now that people are doing things from online forums, what it means is people will be able to share more and more data, and they will be able to actually target them with personalized stuff. So I will skip this thing. What I'm just bringing in here is the perspective of the retail industry and how it got hit. So if you look at this, the retail industry got hit negatively earlier because of lack of employees, lack of supply. So the yellow line here shows the actual impact on the retail industry. So because of this, there are three key priorities. There are priority zones which we have defined for that. So there are in the zone 1, which is first 10 months, there will be sharp increase in the online and omnichannel shopping. So people will be not visiting stores less, rather they would want to do online shopping. And then shop in the demand for essential, they will not be spending money on non-essential things. So there is a need of efficient inventory management, because there might be certain things which are in high demand. There are certain things which are completely in low demand. For example, fashion is something which has got hit completely. So identifying which will be in high demand, which will be in low demand is something which is very essential in this zone. So then a later point of time, there is a need of collaborative supply chain, touchless also automation of operations, advanced demand forecasting systems, as well as quite a few other things we have identified. So what is it bringing out? So it's saying that, see, the priorities of the industry change in these zones, and based on that, the need of actually building tools using AI, and most of these tools actually need AI, also change. So there are some long-term goals, but there are essentially short-term goals for which we have to be catering to. So if you look at the AI influence in overall retail at this point of time, see there are highlights of high impact, moderate impact, and low impact. So if you see earlier, before COVID, right, there were quite a few moderate impact components like catalog management, contact center, virtual assistants, prediction AI, and these are some of them. And high impact ones are the CRM, marketing system, and all were using some of the high impact AI. Whereas if you see today, post-COVID, because of the disruption it has brought out, the high impact components have gone up. So what it means is the AI is going to play a major role in these purple components. So the scope of AI has opened up suddenly. So it's not that companies did not plan for their AI adoption. AI was getting adopted earlier as well. But what happened due to COVID is the process of adopting got expedited. Also, the focus changed from the conventional view of industry to a post-COVID word of industry. For the lack of better word, I can use say post-COVID view of industry. So because of this, what happens is the AI problems pertaining to these areas get actually larger attention now. The industry will start looking at publications in these areas, as well as people will be starting more in these, working more in these areas. So you'll start seeing a push in the knowledge, boundary of knowledge in these areas. So that is something you will be able to see. So these are 5 themes we are talking about: the hyper automation in supply chain, omnichannel experience and availability, self-serve in-store experience, and then expanded security and safety. And finally, the hyper-personalization of customers. So these are 5 areas which we see as a high AI adoption areas in next 3 to 4 years in the space of retail. So we have also identified quite a few use cases. For probably these are some use cases which you would want to look at and pursue research on these kind of areas as well. So we have been picking up some of them, and we have been also working on, but this is something which we definitely want to see how the community works towards. So there are some of the decision AI use cases, experience AI use cases are there, and as well as there are research AI use cases. For example, multimodal demand forecasting is something we are working on, as well as contactless vendor contact management using NLP and ML. Voice and gesture-based shopping is something we have been working on. I'll showcase this one of the demos. So we have been taking care of these research areas as well. So this is something which probably a research community should also be looking at as a larger set of problems. So because an organization cannot work on all these problems, we will be able to pick and choose what suits us. So these are the three zones for which we have listed down the use cases. I'll just flash them and say that, see, this is the exhaustiveness we show in actually analyzing the use cases which are relevant to what kind of zone. But one of the demos I wanted to show is the smart window, which is a touchless shopping experience which we have built.
Hi. Okay then.
So what happened is, this is a kiosk which you can deploy anywhere, and this has a high definition camera or 720p camera based on what we can afford, and also is connected to a deep learning server in the back end. It can be a normal GPU based desktop, or it can be a cloud based thing. So it identifies the person who is coming in based on some face recognition as well as other features which we have used. And once the person comes in, so because now that it has identified who is it, so if you see here, right, so just a minute.
Hi.
So you can see the identification of the person, and then based on that, sorry, I don't know what is happening.
Hi.
So the categories are flashed. These are categories which are special for that person based on the usage. So their voice command is being used.
The next please. Oh wow, product features. Categories again. Accessories. The next one, watches maybe? Nice. Another option? Wow, these are some great options.
So this is a gesture-based system where this is a non-intrusive system where he's selecting a category based on the gesture. So he said category 2, where that's where it started showing shirts. So he can navigate using gesture. So these are some things which can be actually deployed at regular retail stores where there is a lot of noise and people cannot give voice commands and all. So he can also check out using grab sign, and once again go on browsing things. So, and once again, you can see the products are related to the demography of the user. So there is a personalization which is done in the backend. So, and also user can feel safe about the privacy of the data, because ultimately every user has a session, even though it is an open kiosk. So the another demo is about self-learning, continuously learning virtual assistant, which is once again a front end for most of our offerings, what we do, because ultimately a natural language to command generation is one of the major areas. So what we do here is that we are showcasing one of the demos of client who is a transport client, who has a manufacturing center for OBUs, who gives OBUs to the truck drivers, and truck drivers actually use them to pass through the tolls. So there are questions asked like, how can I block my stolen card or something like that? And then there are various ways of asking the same question, so the system understands that. Once again, we use a LSTM based system in the backend here. And then quite a few other CNN based classification also we do for certain kind of noise elimination. So there is also a context modeling here. So there are context switches which are easily taken care of. So for example, the question is different in this case, but it can easily understand that it has to change its context. It understands that there is also a problem with the questions. This is something which is not easily available on any of the cloud-based chatbot systems, where it says, okay, it recommends a separate query, as well as it says, okay, do you want to connect to a colleague who is a real human being? So you can select to choose that, and ultimately, if not, you can actually select the option which is provided, or even exit as well. So you can also give a feedback, and based on this, there is a learning which is happening, and so one can actually choose certain options based on the feedback, and these options are given based on the feedback to the user to understand whether they are catering to the user's need, or if not, then the users can say that, okay, connect me to the agent. In case of actually not having an agent available, it will ask for the contact information and take an appointment with you, and then actually dumps it in the database, and a trigger goes to the agent to give a call during that time. So ultimately, what I am trying to get to is that this is one more reason, this is one more way of actually making sure that the post-COVID world starts operating from distance and start doing various operations like actually taking care of their OBUs, taking care of shopping, taking care of their banking. So virtual assistants are going to be very large, impactful entities in this. So I think I would rather stop here. So the recommendation for the retail industry, this is what we are doing. So this was once again applied recommendation. So multimodal product forecasting is something I'm sure which is going to be very much useful. Intelligent virtual assistants with more AR/VR capabilities, I think, are going to be appreciated. Hyper automation for warehouses and logistics, once again, are highly essential. And revolutionizing shopping experience with easy self-service experience is important. And advanced and seamless user authentication, security, and safety mechanisms are useful. So that's, I think, the overall gist of what I wanted to tell. These are the areas in which I think you can also pursue researches. That's what we are also doing. So I think we will have a better word tomorrow if we do this. Thank you.
Thank you so much, sir. I would request the audience members to post their questions, any questions that they have in the chat box, so that Dr. Kulkarni can answer them. So while the audience members are going to post their questions, I have something, sir. Are any such kiosk, like you showed for smart retail, any kiosk being envisioned for the medical domain? I mean, there are a lot of patients who need, intensive care, and
right. So there is, I mean, I'm sure there are quite a few of them. So we do not work in the area of medical, but what I know about is, for example, Bangalore large hospitals had this kind of kiosks to actually issue tokens in the early stage of Corona. So what they did is they asked some basic questions, and when actually the patient answered, they also had sensors of temperature monitoring and all, which I think Manipal Hospital in Bangalore had it or something like Manipal or Apollo, I'm not sure, but they had this kind of kiosks. So it's not very difficult to build this kind of things. Only a few of the changes have to be done. There are certain other inputs which have to be collected, like the temperature and all those kind of things that can be connected to IoT sensors.
Thank you for answering these questions. If the audience members have any more questions, please post them in the chat box. I would request them to post them in the chat box.
There seems to be no question. That's fine, I think. Yeah.
I hope they have questions for you later on and they can connect with you on LinkedIn or any other social media for that.
Yeah, I think, I have a 3 o'clock as the meeting, so I think.
Thank you, sir. Thank you for your informative presentation, sir. We were honored to have you in this forum today. Thank you so much for your time and have a nice day.
Thank you. See you. Thank you. All the best. Yeah.
Thank you, sir. For the next keynote speech session, it is my great honor to invite Professor Dr. Christopher Nugent. Dr. Nugent is the director of the Computer Science Research Institute and holds the position of Professor of Biomedical Engineering. He is based within the School of Computing and Mathematics at Ulster University. He received a DPhil in Biomedical Engineering from Ulster University and has held the positions of Senior Lecturer and Reader within the Faculty of Computing and Engineering before his appointment as Professor of Biomedical Engineering in 2008. In 2016, he was awarded the Senior Distinguished Research Fellowship from Ulster University. His research within biomedical engineering addresses the themes of the development and evaluation of technologies to support ambient-assisted living. Specifically, this has involved research in the topics of mobile-based reminding solutions, activity recognition and behavior modeling, and more recently, technology adoption modeling. He has published extensively in these with papers spanning theoretical, clinical, and biomedical engineering domains. Dr. Nugent is the group leader of the Smart Environments Research Group and also the co-PI of the Connected Health Innovation Center at Ulster University. Now I would request Dr. Nugent to start his speech titled AI for Human Activity Recognition in Smart Environment. It's over to you, sir.
Okay, good afternoon, and thank you very much. Can I check, can you hear me and see me and view my slides okay?
Yes, sir, it's okay. Everything's fine.
Okay, so good afternoon, everyone. My name is Chris Nugent. I come from the School of Computing in Ulster University in Northern Ireland in UK. And the title of my presentation today is AI for Human Activity Recognition in Smart Environments. So I wanted to start off the presentation by contextualizing the problem of human activity recognition and really why we have to consider this as something to undertake and investigate what computational approaches and data can be gathered. And then I want to introduce to you some of the work that we're involved in at the university and some of the solutions, some of the AI solutions that we have been involved in. So just to start off, I think everybody is aware that the population as a whole is changing in terms of its dynamic, in terms of its size, in terms of the number of elderly people in the population, and there is a general move towards trying to improve the quality of life for everyone, especially those in the elderly category, to allow them to remain living in their own homes independently for a longer period of time. And the opportunity here is that we can use technology-based solutions to provide an enriched environment which can provide some level of support for individuals. So one of the key components in this whole process of trying to offer an improved quality of life with technology is to understand or gain an appreciation of the basic activity that a person is undertaking at any point in time within the environment. And if we can understand what that activity is, there are a number of very, very important assessments that we can undertake and link with the health and well-being assessment of that person. So if we can understand what activity they are undertaking, we can assume a confirmation of that can be made if someone hasn't undertaken an activity which they should have done, we can offer a prompt to try and engage them with the environment. And thirdly and finally, we can monitor changes in behaviour over time, so we can understand how long a person engaged in an activity, and we can compare that 1 week later, 1 month later, 6 months later, and try and see is there any deterioration in health and behaviour. So at the bottom of my slide, you can see, maybe just put on my pointer here. Yeah, can you see my pointer? Just at that diagram, we have an environment in the center, and I've broken this up into 3 very, very simple components: the sensing technology, which can gather information from the environment; the actuating technology, which can control the environment; and the main part that I want to talk about today is the data process, and what can we do and what tools and techniques can be deployed within the smart environment itself. So from a healthcare perspective, these are examples of the forms that a healthcare professional would complete. They would visit somebody's home. They would ask questions about their ability to bathe, their ability to dress, to use the bathroom, their ability to eat, and all of those can be scored, and a measure of level of independence can be made. And that measure is then used as a proxy for the ability for that person to live on their own, or if some form or additional form of health or help or support is required. So these are fairly standard forms. That's a CAT index. There's a Bartel index. The big challenge with these would be if a human, as opposed to a computational approach, makes the assessment, there is variation and there's a lack of consistency. So if we can put in place an automated approach, we avoid any subjectivity in the assessment, and also it gives us a consistency if we perform a longitudinal analysis. So if we move then to how can we address this problem from a computational point of view, ADLs, or activities of daily living, this is really what we are trying to assess in this process. And what we can do is we can identify at any point in time, if we have a technology enriched environment, what a person is doing in that environment, where they are, and what objects that they are interacting with. And from that, we can build an interrelationship and start to model what the activity of any individual person is. So in the example I've shown here, on the bottom of the diagram, we can see the sensor technology. These can then be mapped onto individual events in our modeling, and then we can combine these interrelationships to produce an indication of what the activity itself is. So we can start to build in information like a location, which room an activity is being performed in, the time of the day, and link that to various sensor activations. So if for example, we understand a person is in the kitchen and it's morning time and they take some food from the fridge, we can build that into our model of processing information related to the activity of eating at breakfast time. There's 2 approaches that we can model our activities of daily living within a smart environment. One is to take a knowledge-driven approach where we glean information from experts and those with domain knowledge to try and establish what the interrelationship between the sensors are like. And the second approach is to take a more data-driven approach where we can take large amounts of data, whether it's annotated or not, or labeled or not, and try and build models through AI or machine learning. That's really what I want to talk about today. So what we want to do is take the approach or replace the clinical approach of the measures like the Bartel index or the CATS index, and we want to create a behavioral model, but rather than use a knowledge-driven approach, we're interested to look at data-driven approaches. So if we compare the 2 different types of ways that we can assess or we can develop these solutions within smart environments, at the top we have the knowledge-driven architecture, and largely here is where the knowledge would be injected by the domain expert to give us some guidance in terms of what the interrelationship between sensors are like, what would be the typical flow of information, what would be the typical types of sub-activities that would be involved or should be included or modeled in a larger activity framework. So this is our knowledge-driven approach, and at the bottom I've showed a very, very simplistic representation of a data-driven approach where we have a large amount of data, and this could be labeled or unlabeled, and then we may wish to enter into a feature engineering stage before we train some model based on that data set, which will be representative of the problem that we're trying to address. So I want to consider, for the purposes of today, in this conference, in this event, some data-driven approaches that we have been involved in our group at Ulster University. So I just check for a second. Can you still see the slides and hear me and see me okay?
Yes, sir, you are audible, and the slides are also visible.
Okay, perfect. Thank you. Okay, so that was the sort of first part of the presentation, just to introduce the context. I want to now show you the types of data that we work with within smart environments, and after we understand the data, we can then consider what the actual models or the AI techniques themselves would look like. So one of the most common approaches or sensing technologies that we would use in a smart environment would be to come from an accelerometer, and the most common place that we would find accelerometers would be on your mobile phone. So in this example, a colleague of mine has a mobile phone that's strapped to his waist, and you can see on the graph here, this is the magnitude of a triaxial accelerometer. Is showing different footprints of the activities as he moves around the smart environment. This is our smart living room within the university. So you can see the different profiles as he stands, as he sits, and this is an exaggerated fall, but you can see that we have quite a significant change in the accelerometry signal. So this would be one of the primary sources of information that we could use, or we would consider to use within smart environments. And it's becoming more and more popular because we can glean this information from a mobile phone. And with the power and the recent advances in mobile phone technology, it becomes very, very popular for algorithms to be deployed on the phones themselves rather than some cloud-based services. So accelerometry is one of the main sensing technologies that is currently being used within smart environments. This is what a triaxial accelerometry data recording would look like. This is about 40 minutes worth of data. And there's two real challenges from a computational perspective that we have to address when we work with this type of multivariate data. You can see here various changes in the signal. So hopefully you can see my laser pointer on the screen. So these are different types of activities, as somebody is standing, somebody is sleeping here, somebody is walking. This is quite exaggerated activity when someone is running, somebody is sitting here, and someone is doing some housework. So the two processing elements that we have to be aware of whenever we consider using this type of data is first the change point from one activity to the next. So here we have standing to somebody exiting from their seat to sleeping. So we have to be able to identify and segment the signal. And then the second point is where we would introduce more of a machine learning solution to identify the individual patterns of the accelerometry signal, to identify the differences between walking or running or sweeping or some other activity. So these remember are the end goal that we want to identify. What is the behavior, what is the activity that the person within their home environment is currently undertaking. A second type of sensor technology that we consider, and maybe you wouldn't consider video to be a sensor, but in the context of a smart home, we do. Obviously, this provides a very, very rich level of information. There's quite a lot going on in this slide, so I'll maybe show it 2 times just to explain it. So in the top right-hand corner here, sorry, the top left-hand corner, we have one person who's moving around in a circle, which is very typical of a person with, for example, dementia, who is agitated. And the person walking, this is maybe just some normal behavior, so there's no health concern with the second person. So that's a very complex problem for us to process. We have to identify issues of multiple occupancy. We have to identify the different behavioral patterns of each of the individuals within the environment, and we have to identify are any of the patterns random or are they repetitive. If they are repetitive like this, it's an indication that there's a health problem, and if they're random like this person in the environment, then this is fairly normal behavior, and we can just let that go. The big issue that obviously we have with the use of video is the invasion of privacy and the ethical issues that comes with it. On the bottom right-hand corner of the slide, you can see we've converted the video to blobs, but still this level of video is not acceptable in a number of environments to make a measurement or of the recording of behavior. And just one further example where we can link both contact sensors and video sensors. As this person moves in the environment and they open the doors, that triggers a contact sensor. But we can also track the person themselves by their profile in this RGB scene. And here we have a different person who comes into the environment, and their RGB profile is different. So you can see here in the information that we record that it's a different color profile from the first person who entered. We can also, all of these cupboards and objects in the environment, this is a smart kitchen that we have within our university. Anything that anybody interacts with here will trigger some event or some message that we record in their database. And in this processing, we can record, or we can monitor the difference, or we can identify that there are two people in the environment and which objects that they are interacting with. So this is really a fusion of two different types of sensor technologies. So lots of opportunities for us to gather data. The challenge then becomes how can we curate all of the data, and how can we develop some computational models to reach our end goal of activity recognition. So data sets and data is always a challenge. I'm sure in the past few days this issue has been raised and will be raised again and in other events. And certainly within the field of activity recognition and within smart environments, it remains to be a challenge to have a large, high quality data set that is fully annotated, which covers a large breadth of activities that can be used for the development of data-driven classification models. So part of our work within the university and in our international network has been to establish an open data repository where colleagues who work on the collection of various forms of activities within smart environments can share the protocol of their data collection, can share the protocol of the format of how the data is stored, which allows us to join all of the data sets together. We can make a measure of the quality of the data, and we can then share that back with the community to allow provision of a larger set of resources for the development of data-driven models. What this allows us to do, and if you just follow this diagram on the right of the slide, we can have data collection at multiple sites that follow exactly the same protocol and the same format. These can be uploaded onto our repository, and they can all be combined together to give a much larger data set than any of these in isolation. And then from a development point of view, each of the individual sites can develop their own algorithm, but can be evaluated within the context of our open data initiative. So it allows, let's say, an objective assessment across a number of, an objective and independent assessment across a number of different sites and organizations for the assessment of the performance of the algorithms. So some of the, just to give you an example now of some of the models that we've worked in our lab, we've built a simulation tool as well to allow us to generate some data. So this allows us to create a smart environment. We can drop onto the environment a number of soft sensors, and we can allow a person or an avatar to walk through the environment, and we can generate our data set. So we produced an artificial data set here with just over 600 instances, and We then wanted to consider the development of our activity recognition models and how we could produce the best solution to give us the highest performance for the activities that were being undertaken. So if I switch a little bit then to the technical details of our activity recognition models, what we wanted to do was to maximize the generalization, obviously, as any machine learning development aspires to do. We wanted to avoid overfitting of the data, which is very, very common. And we followed an approach with our collaborators to minimize the generalization error during training by taking into consideration both the training error, which would be standard, and also a measure of the stochastic sensitivity measure. So this is a detail of the approach that we used in conjunction with our colleagues from South China University of Technology, Professor Wing, and this is a localized error model and generalization error model, which takes into account both the training error, which would be common in a gradient descent approach, and also the sensitivity measure. And we used this with our radial basis function and compared it with a number of other approaches based on the data that we generated from our simulator. So the first results that I want to show, these are quite interesting. So this is the radial basis function neural network results that we generated after we had developed our solution based on the minimization of the localized generalization error. So it performed very, very well, indeed gave us the best approach in comparison with the other benchmarks that we used. But quite interestingly, at the time, we did investigate both a deep and a shallow neural network paradigm. And in this case, the shallow neural network outperformed the deep model, really because of the lack of the availability of data and the breadth of the data that we had in our data set. So this, I guess, is a lesson or quite interesting, not to just assume that a deep learning solution is going to be superior to a shallow approach without taking into consideration the constraints or the amount of data that was available. So what we then did was we progressed our work to look beyond the sensing technologies that I mentioned, to try and offer a contribution or an extension and innovation in our work from both the computational point of view, but also the sensing technology perspective. So I showed earlier on some video clips and mentioned about the ethical implications. What we are interested to consider now is, you can see here on the left-hand side of the screen, this is our RGB video. And on the right-hand side, this is a low-resolution thermal camera of a 32 by 32 array of thermal piles. So although here in the thermal camera, we reduce significantly the resolution, we do address the issue of privacy and ethics, but we make our computational problem much more complex, because we have removed a lot of the granularity of what is undertaken and what is going on within the scene of the person's environment. But you can see here, well, I don't know how well that's being broadcast to your own computers, but you can see the person moving in the thermal image, and here this is where the person has a hot drink, and we have a hot spot within the image. So our work has been to investigate how can we use this new type of thermal sensing, and how can we develop new computational models which can process the data that can be gleaned from the thermal sensor. The type of activities that we can detect here would be levels of movement or sedentary behavior if somebody has fallen, and if there's some agitation, and at a finer level, the completion of ADLs, like making a drink, or watching various or interacting with various objects within the environment. So again, as part of our work in the university, we have built the thermal camera solution ourselves. So this is our thermal camera at the minute. It streams a 32 by 32 array of the thermal images. We've also built an aggregation platform to link it with other sensors, and this is a very simple. It's a wireless battery operated solution. And this is the type of information that can be screened back to our central management recording center. So we have a platform, an aggregation platform that we've built, referred to as Sensor Central, which allows us to integrate and synchronize various forms of heterogeneous sensors that you can see. And we've offered a smart home in a box solution. So what we've done is we've taken this thermal image and we have built out a number of machine learning approaches to identify, in the examples that I'm going to show you now, fall detection and multiple occupancy based on this 32 by 32 thermal pile array. So here we have an example of an unfortunate fall. It is simulated. This is in our lab in the university, and this is one of my colleagues. So you can see here on the right-hand side the thermal image, and this is what we want to detect from the machine learning or the AI solution. And interestingly, I don't know how clear that is being projected on your screen, but there is a thermal trace that is left as someone moves around the environment. So the heat has been transferred by this person onto the seat. These images are just flipped in the slides. So we can have some confusion to understand this is the person, this is the fall, but this is a thermal trace from some point in time where they had been sitting in the environment. So what we did was we built a solution with a convolutional neural network, very standard approach. This is our thermal sensor that we built. We collected our data. And we had two simple outputs from our classifier, a fall or a no fall. And to help us to have a larger data set, we looked at the translation and rotation of our images. So we flipped our images, we stretched them, and we rotated them to increase the size of the data set that we collected within our lab by fourfold. So in the first instance, the performance figures that we got, and again, we've just used very standard out of the box convolutional neural networks. These are the parameters. We looked at three different options. In terms of single occupancy fall detection, we reached nearly 92%. And whenever we consider multiple occupancy fall detection, so this means we have two people in the environment, and one person falls and one person doesn't, this becomes much more complicated for us. And with this model that I presented, we achieved just under 86% performance. So what we wanted to do was try and boost the performance both of the multiple occupancy and instance with fall detection, and also look, can we increase the performance of the single occupancy fall detection. So we went back and brought in our work that we had that I presented with the real basis functions to try and understand, was there some way that this is a single occupancy image with a fall, and this is a multiple occupancy image with a fall and a person standing. So we wanted to create an architecture that allows us to boost the performance of both detection of multiple people in the environment, and also to improve the detection when a person has actually fallen. So what we have ended up with is quite an elegant solution, where in the first instance we decompose our image into multiple images. So this allows us to identify how many people are in the environment, and then we can binarize the images and process each of the images as a scene with only one person in it. So we reduced the complexity of a multiple occupancy scenario by decomposition of multiple persons into a number of single person images. we developed our neural network solutions, and the performance was really significantly enhanced here. And whenever we used our radial basis function approach with a single occupancy model, we were able to increase the performance on the same data set to 98.4%. And with our multiple occupancy fall detection, we were able to increase our performance from, in the previous example here, you can see it was just under 86%, and we were able to increase it with this architecture by decomposing the multiple occupancy images and the single occupancy images to just under 95%. So just to summarize, I'm conscious of the time. This is my last slide. I think it is clear that there are benefits to be attained by monitoring people within their own home and through the use of technology. And as I said at the very start, the goal is to identify what is the activity that the person is currently undertaking, and then from there we can gather a wealth of information and offer various degrees of support. And there are lots of sensing technologies that are currently available to us that we can use. And what we had focused on in this current, or what I had presented in this current example, was the use of a low resolution thermal sensor in conjunction with the use of a radial basis function neural network that was trained to take into consideration both the minimization of the generalization error and the stochastic sensitivity measure. We showed that our approach was successful when compared with the benchmarks. And our next stage, and what we're currently working on, we're very, very close to reaching a solution, is to move all of our algorithms, all of our neural networks onto the thermal sensor platform itself to produce one standalone device. At the moment, we stream the data from the thermal sensor to the cloud and process there, but we're very close to having produced a resource-constrained solution. So that's everything that I wanted to say. Thank you very much for taking the time to come along and listen to the presentation today. I hope that was interesting, and I guess if there's any questions, we do have a few minutes, and I could take those now.
Thank you, sir. Thank you for your presentation. I would like to request the audience members to post their questions in the chat box so that Dr. Nugent can answer them. So there is a comment as well as a question by our Honorable Vice Chancellor, sir. Your domain work is really interesting, and I understand that you are doing wonderful work in the domain. It's a very general question. If there are any misactivities within a crowd, is it possible for AI algorithms to detect those? Are the image processing algorithms strong enough to detect the movements for the AI algorithms to work properly in those cases?
Yeah, that's an excellent question. And I should have really presented some limitations in the results that I presented, that we didn't consider in our training and testing data any activities that weren't previously considered. So to be honest, in answer to your question, the solution that I presented today wouldn't be able to identify any activities that weren't included in the training data. However, there are a number of other solutions that could be used, mainly in the domain, I believe, of transfer learning, where we could extend the output and the ability of the classifiers to work towards new activities that weren't built into the training data. So in the solution that I presented today, no, it's not possible, but I do know that other researchers have been trying to identify and to try and produce solutions, or identify some activities that haven't been fully labeled and haven't been fully included within the learning process.
Thank you, sir. Thank you for answering this question. If there are any more questions from the audience members, please post them in the chat box. So while we wait for the audience members, I have a very simple question. Sir, I think we saw in your presentation that like For the patients of dementia, the activity recognition model was built. So my question is, are any other models being built for other illnesses which are exclusive to elderly patients such as Parkinson or Alzheimer's?
Yeah. So, I should have said at the very start, our group focuses quite a lot on the application domain of supporting people with dementia, and that's why the work that I've been involved in largely focuses around the detection of activities and how that can be used to support delivery of reminding technologies. But this could have been used, for example, for Parkinson's disease to track the impact of medication change and how that is supporting the progression of the disease, or it could be used for post-stroke rehabilitation, for example, or monitoring the behavior of depression. So yes, lots and lots of various health conditions. I guess the solutions I presented are largely agnostic to the health problem, but at some point in time, a level of a change and some fine tuning has to be made to link it to the specific application domain.
Thank you, sir. Thank you for your answer. And I think there is just one more comment by Bharat Ram that in image processing, if a person crosses or align, then we would log only one person if we use a single camera. But if we use multiple camera for the purpose, won't it be a waste of hardware? So is there any way we can tackle it?
Just let me read this question. I understand it properly. One person, no, one person using. If we do use multiple, won't it be a waste of hardware? Yes. Okay. So if whoever asked me that question, if you could send me an email, I can send you a paper that we just published where we studied the use of 5 thermal cameras within a smart environment. So we had a thermal camera on the ceiling, very similar to what I showed today in the videos, and we augmented that with a thermal camera in each of the corners of the room to allow us to take 5 different fields of view of the environment, and we studied the cost-benefit analysis of the increase in performance of multiple cameras versus the additional cost that would include for installation. So I don't know if it's a waste of hardware. It is additional cost, but with the cost you have an increase in performance. So a decision has to be made at the stage of deployment. Do you want in performance or a slightly lower performance and lower cost acceptable? So if you would like to send me an email, then I can send those details through and give you a deeper analysis of the work that we've taken.
Sir, he has requested for you to share your email ID. Thank you, sir. Thank you for sharing your mail ID. Okay. I don't think there are any more questions which are forthcoming. So thank you, Dr. Nugent, for this excellent presentation. So we got new insights into the domain of artificial intelligence, especially for assisted living. We were honored to have you in this forum today, sir. Thank you so much for your time.
Thank you, and thanks again for the opportunity, and very nice to meet everybody today. Thank you.
Thank you, sir. Have a nice day.
Bye.
Now for the second research keynote speech of the day, I would like to invite Professor Dr. Sandeep Joshi. Dr. Joshi is a senior academician with experience in providing visionary leadership to students and imparting quality management education to a wide range of aspiring professionals. A doctorate in computer science and engineering, he has mentored and guided the students towards a successful future as professor at Manipal University, Jaipur. His area of research interests include computer network protocol, computer network and security, advanced data structure and algorithms, web technology, and system software engineering. During his tenure, he has proven competencies in designing course curriculum and implementing innovative instructional methodologies and equipped to provide authoritative leadership to both academic as well as administrative personnel in the wider issues of managing an academic institution of higher learning. I would now request Professor Joshi to start his keynote speech on framework to integrate AI into 5G networks. It's over to you, Professor Joshi.
Very good afternoon to all.
Good afternoon, sir.
Yeah, I hope the slide is visible to you all.
Yes, sir, the slide is visible.
So thanks, Mr. Vasu, for introducing me and telling me about my academic career. As far as my topic concerned, today I'm going to discuss a framework to integrate artificial intelligence into 5G networks. As we know that there are the two different components. One is the 5G network, second one is the artificial intelligence. Whenever we see the series of the network starting from 3G, 4G, 5G like this one, then we can easily understand what is the differences come up from there. Mainly the differences come up in the speed, we can say the less latency, we can say more bandwidth. So like that there are differences come up from the network range to range. But now the scenario changed when in the case of the network, there are many new things come up, like as the artificial intelligence, augmented, we can see reality, then virtual concept, many things come up. Then how it's going to be integrated? So in that case, the role of the AI come up over there. So as far as the, oh, sorry, 1 minute. Yeah. Showing content. 1 minute. Okay. So I think the contents is not visual anyhow. Yeah. So yeah, I don't know what the issue, but as far as the content concerned, I'm going to discuss about the AI and its integration with the 5G network and what are the possibilities of the AI where the 5G network can be integrated. So moving on the next slide, as far as the 5G network concerned, we understand nowadays the network becomes so much complicated, heterogeneous, as well as we can say it becomes in the new dimension with the network infrastructure. So in that case, now there's one more things come up. Whenever you compare with the 4G network, 4G network, there is a, we can say compare it with the 5G network, then they come up with the bandwidth, speed and latency. Apart from these things, is it possible to integrate somehow the intelligence? Because the network is also required very small. So here it is just an idea how the 5G network can be more smart towards the action taken or towards the, we can say, the dynamic approach. So full, I think there are some issues with the slide. Or the contents are not visible. 1 minute. Maybe because of the some Hmm? 1 minute. Yeah, I think now it is correctly visible. So we were discussing about the 5G networks. I just want to confirm the screen is visible to your. Yeah, anyone confirmation from your side? Yes, either the screen is visible.
Yes, sir, it is visible.
Thank you. So as far as the 5G network, we understand. Now, as far as the artificial intelligence concerned, there are many complex problems that through the artificial intelligence or through the smartness of AI integrated with the machine learning that can be incorporated in the network. So here there are the few names like as the recurrent neural network for multi-input, we can say multi-output MIMO, then fading channel prediction, deep learning based resource allocation, supervised learning for network security, reinforcement learning in cognitive radio, and intelligent network management. So like that, the various areas where the artificial intelligence apply as we know. So now the question is how these things can be integrated with the network and how it's going to be useful for making the AI. Yeah, 1 minute, please. There is a challenge. So I hope now, because we are in totally the new scenario of the online things, somehow there are some technical glitches now, I think visible to you. And I think it's good that we are in the new paradigm, new concept by using the online concept. So yes, these are the area where the artificial intelligence has to work. Now, if we integrate the AI with the network, so yes, as far as the network concerned, we understand that how complicated network nowadays. So as far as the AI concerned, through what concept we can integrate it so the network becomes as smart. So it is means that more advanced radio transmission, resource allocation, and network techniques are required to be developed. Fulfilling these tasks is challenging since network infrastructure become increasing complicated and heterogeneous. So our solution, the promising solution is the AI technology, which has been explored to provide solution ranging from channel prediction to autonomous network management, as well as the network security. So since there are the various parameters or the various, we can say the components where the AI can be integrated and provide the solution to the network. However, the state of the art of integrating AI into wireless network is mainly limited to use a dedicated algorithm to tackle a specific problem. So in general, nowadays, there is no generalized concept of AI is going to apply on the network. It is work like that there are specific algorithm is available for a problem. So whenever it's going to be active, then that is going to work. Otherwise, because it is not like that the generalized one algorithm is available and just triggering that is going to solve the problem. So our proposal is, or not a proposal, we can say one concept. What is this concept? A unified framework that can make full use of AI capability to solve a wide variety of network problems, still an open issue. So it means the concept what we are introducing over here, the concept of intelligence slicing, wherein AI module is instant and deployed on demand. Meaning there are different type of the slices specific to an AI algorithm is applied over there. And basis on that, whenever any specific problem come up, either the data manager or we can say the network manager has to trigger that AI algorithm, and then the algorithm is going to be active based on the different kind of the slices over there. So the intelligence slices are applied to conduct different intelligent tasks with the flexibility of accommodating arbitrary AI algorithm, as I already stated. Two example slices like as a neural network based channel prediction or anomaly detection based industrial network security. However, there is a two example is given, but as far as the AI and network integration concerned, there are many areas that could be integrated with the network. There is still some challenges as discussed because The AI technology into wireless networks is mainly limited to use as a dedicated AI algorithm to tackle a specific problem. Yes, because there are different algorithms here required for a problem specific. An intelligent framework or software-defined virtualized infrastructure is merely focused on applying AI dedicated for network management. A framework that can take advantage of AI technologies to solve network problems in a unified manner is still an open issue. Again, the same challenge is appearing again, that there is no specific algorithm is available. However, the algorithms are available. The many algorithms are going to be used as far as the specific problem concerned. So what we are proposing here, that is the unified framework. What the unified framework is saying, the design of a unified framework that has generally and scalability to integrate AI to conduct intelligent tasks for all network aspects, ranging from radio channel to signal processing, from source allocation to network slicing, orchestration, from local control to end-to-end optimization. The concept of intelligent slicing with the flexibility to instant deploy, scale, reconfigure, and transfer AI functional module on demand. Yeah, as I earlier stated, on the demand is providing the AI algorithm and is going to be trigger for the solution. And for every slicing, there is a, we can say, invoking as well as the closing is required in case of the slicing, the work over there. And intelligent slices can be deployed in an arbitrary network entity to solve a problem by means of selecting the best algorithm specifically optimized for this problem. Yes, because it's going to be, we can store on the cloud also on the basis on the specific requirement and depend on the optimization parameter the algorithm is going to select. Two examples already discussed in the previous slides about the recurrent neural network based MIMO channel prediction to improve the accuracy of transmitter antenna selection and security anomaly detection in industrial network. As far as the unified AI framework concerned, yes, there is a framework. Second one is the intelligent slicing. So how the intelligent slicings are incorporated in the framework, that we'll see in the next slide. Now, this is again at the starting, I told you this is the one concept. So now we can see a unified AI framework based on intelligent slicing over the software-defined virtualized 5G infrastructure. Now we can see there is a network. In the network, we can see suppose there is a computing, networking, storage. There are three areas. They are integrated through the SDN controller. Now, as far as the intelligent slices, we can see there are the different type of the slices, like the security, we can say mobile load balancing, video call, whatever the algorithm slices, they are integrated with the network. Now we see slices are with the slice manager as well as the data manager. Now, what is the role of the slice manager and data manager over here? We'll discuss in the next slide. However, I just want to interfere over here. The slice manager is role over here because they are the all the slices have the different type of the algorithms embedded over there. So whenever a specific algorithm, which algorithm is going to invoke and which one is going to be optimized and it's invoking and closing. So all these work are going to be done by the slice manager. Like that, the role of the data manager, the transfer of the data and so we can say applying the AI algorithm and its results, that is going to be taken care by data manager. So just see on the next slide. So as far as we have seen the previous slide, as far as if it is integrated with the software-defined network and network fusion virtualization, were initially deployed as an independent networking paradigm by open networking. later on, because it was initially, as we can say, an open environment, but later on, whenever it's going to be integrated with the slices, then the framework come up. So it was earlier used by the European standard, we can say, but later on, now in the, it is integrated with the AI and coming with the various applications. So as far as the virtual computing, storage, and networking resources under the control of virtualized infrastructure manager can be leveraged by SDN to facilitate the flexibility to program the underlying network. So the scenario is like that, the integrating of AI with the 5G network, then the cloud computing is also coming in the, we can say, scenario. The virtualization also come up over there, how the data is going to be stored, how the slices is going to be, we can say, invoked for the specific problem. Taking advantage of SDN and NFV network slicing that allow multiple virtual networks to provide dedicated functionality specific to the service or customer can be instanted on the top of a shared physical infrastructure where physical network functions, PNF, are used in order to represent legacy components. So as far as the intelligence slices, as the diagrammatically we have seen in the previous slides, AI functional modules that are deployed in the network to individually or collaboratively accomplish intelligent tasks such as radio scheduling in a MIMO system, MLB, video, QoE, provisioning, and security. So we have seen in the diagram in the previous slides how they are connected with the different intelligence slices. Intelligence slices can be instantaneous on demand at different levels to achieve dedicated intelligent tasks with the aid of the most suitable AI algorithm, specially optimized for this task. Although slice is controlled by a centralized entity, it is only logically meaningful. Actually, slice should be physically deployed in a distributed manner close to its functional area to make time-sensitive decisions and offload the traffic passing the core network. Yes, whenever it's going to be deployed, we can say intelligence slices, so there are the other parameters are also going to be taken care during the, we can say, the invoking the algorithm deployed on the intelligence slices. So as far as the intelligence slices, how the or what type of the strategies they are facing over there, or they apply over there. So there is a divide and conquer strategy. Each slice only focus on a dedicated intelligent task with the aid of the best suitable algorithm specially optimized for this task. For instance, a MIMO slice is deployed in a base station. Base station we are targeting in the, we can say, the mobile station, the mobile network, mobile computing. In we can say continuation of that, it deployed in a base station taking advantage of RNN to predict feeding channels so as to intelligently select it, transmit antennas, while another slice for network security can be instantaneous in the data center of an industrial site to detect anomalous traffic. Different slices operate independently so that each slice has a flexibility to instantaneously deploy, reconfigure, and scale in terms of in respective situation. So as earlier stated, the slices are integrated in such a way that yes, they are, we can say, in the bucket form, but they have their independent algorithm. They can optimize independently as well as there is flexible in the nature. So flexible in the deployment, flexibility in the reconfiguration, flexibility in the scaling. So whenever suppose the number of slices we want to increase or decrease, that is also possible. As far as the slice manager's role, as I already stated diagrammatically also, once receive a request for a dedicated intelligence task, the manager instantaneous an intelligence slice following a unified procedure. So yes, there's a AI algorithm is available that is working in the background also. So by using the slice manager will use the AI algorithm also for selecting the slice, which slice is applicable, right? And again, which slice is going to applicable for a specific problem, and it's going to deploy and going to be get the result out of that. During its operation, its life cycle management such as reconfiguring, scaling, and destroying will be conducted by the manager. So in the previous slide, as we discussed, they are, because the slice buckets are scalable, we can say it can be destroyed, it can be, we can say, reconfigured, right? Scalable means increase and decrease of the slices. That is going to be controlled and managed by the slice manager. As far as the data manager concerned, so responsible for acquiring, modeling, processing, transferring, and storing data in a unified and efficient manner. Yes. So what type of the algorithm we applying on the data? And because the slice manager is going to provide the algorithm and data manager is going to provide the data on which the algorithm is going to work. The data can be from both historically offline sources, public or proprietary, and real-time online, collected from complex, heterogeneous, dynamic, and large-scale network. So it means the database we have collected from the various sources, because it's going to what the purpose we have collected the data and what the things we want from the data. So based on that, the algorithm is going to be selected from the intelligence slices and applied it over there. It not only provides data set necessary for training and testing an algorithm, but also delivers monitor data in a timely, securely, and accurately way during the operation of intelligence slice. In fact, these slices, as we have already stated in the previous slides, that in the bucket of the, we can say, the slices, yes, there are not only the neural network based approaches, there are many other approaches can be work for the algorithm that could be applied for the security also. So the life cycle management of the slices, yes, we can say the instantiation, reconfiguration, scaling, transferring. So yes, the four things we already discussed about the these things, how we are going to apply the slices. So the scaling, transferring, we have already discussed the reconfiguration. As the reconfiguration, we discussed that is through the slice manager. So it's going to apply with the coordination with the data manager. Here we can see the diagram and the deployment of the slice or intelligence slice. Here we can say there is a network slice 1, network slice 2, and this is the core network. So now we can easily understand that there is a slice manager is a configure over here and data manager over here. So yes, they are stored on different location. One is, we can say, aligned with the industrial networks, and second one is with the generalized network. So yes, through the net, they are going to be integrated in such a way that whenever whatever data is going to apply, available, the slice manager, depend on the requirement in optimized form, is going to provide the intelligence slice to work on the data, and it is going to provide the result. Especially we can see how in this network, the core network, there is a mobile edge, then is a cloud, as I earlier stated that these things are integrated with the AI framework having the 5G network. Though the concept is only making the, we can say, the network intelligent, so, or we can say smart network through the AI. Again, it's showing, the slide is showing that there is a cyber physical system, as we heard the word about that. So if any kind of the attacks is on this CPS, cyber physical system, so the physical entity can be affected, suffering from a more severe damage and economic loss than that of attack within the cyber world. So what is saying this thing? Whenever such kind of the things is there in case of the attacks, then how the slices is going to work, how the slices become important whenever there is in the case of the cyber world. So as far as the conclusion concerned, as I stated in the starting, that this is one kind of an idea to making the network very smart, integrating the AI algorithms with the 5G network. So the 5G network can take the, we can say, benefit of integration of the AI. However, still there are many challenges that come up because there are the different slices, or we can say the different algorithms are going to be applied, and that is also going to be selected by the slice manager. So this is from my side about the, it is one concept that is introduced in front of you, how the heterogeneous system, the 5G network, is going to be integrated with the AI in the form of the intelligence slices. So thank you, thanks to all for giving the time. I exceed 1 minute. So now it is open. You can ask me the question.
Thank you, sir. The forum is now open for questions. Any questions from the audience? They are requested to post it in the chat box. So we will wait for some time for audience members to post their questions here. Audience members can post their questions in the chat box so that Dr. Joshi can answer them.
Can I stop the screen sharing?
Sorry, sir, didn't get you?
Yes, sir. Yes, sir.
Yeah, okay, thank you.
Sir, I don't see any questions forthcoming, but I'm sure that if the audience members have any questions, they can
Yeah, they can ask.
contact you on the email.
Yeah.
Thank you, sir. Thank you, Dr. Joshi, for delivering an interesting presentation. I'm sure the participants of this conference have greatly benefited from your session. Thank you for gracing us with your presence, sir.
Thank you.
Thank you, sir. Now, please join me in welcoming Dr. Reema Ghosh Chaudhary, EVP and CHRO, Datamatics Global Services Limited. A seasoned HR leader and practitioner with over 2 decades of experience in corporate and academia, Dr. Reema has been instrumental in building technology and leadership capabilities in reputed global enterprises like IBM, Sony Pictures Network India, and Quinox. In her previous roles, she has championed change management in the technology and culture space to bring in the right blend of high-tech and high-touch culture. Dr. Reema has been an international mentor for Middlesex University London and is also a trained instructor by Sony Pictures Entertainment UK on the Energy Project. An alumni of Jadavpur University and a PhD in leadership domain from D.Y. Patil University, Dr. Ghosh Chaudhary has received multiple HR Excellence Awards, including 50 Most Influential HR Tech Leaders 2015 at the World HRD Congress and Young HR Professional of the Year Award at Asia Pacific HRN Congress 2009. Now I would request Dr. Ghosh Chaudhary to deliver his speech titled When Artificial Intelligence Meets Human Intelligence. It's over to you, ma'am.
Thank you for the warm welcome. I so look forward to this session today. Allow me a few seconds while I put up my presentation.
Sure, ma'am.
Is my screen visible?
Yes, ma'am, it is visible.
Okay. Okay, so a very good afternoon to everybody who have taken time out to listen to me in this slot. To be honest, I was a bit lost as to what subject within AI do I cover, because by the time we have reached this particular slot, which is almost towards the end of the conclave, I believe whatever there was to know about AI, people would have known by now. So there have been such esteemed speakers before me. I'm sure loads of subjects have been covered so far. So I thought about it, and then I felt that possibly I could do something which is how we, as in how Datamatics as an organization is treading on the artificial intelligence path, and another segment which is how artificial intelligence can make the human and humane processes much more effective, okay, and much more efficient. So that's how I have structured it today. Yeah. So I had HR for an organization which has about 10,000 plus employees spread over 6 countries with about 550 plus key customers. A huge chunk of them is within the Fortune 500 range. We have 4 global delivery centers. We have global delivery centers in 4 regions, publicly listed company. And we have been able to make very strong forays into the Industry 4.0 trends, by way of which we have been able to kind of create an impact in all the different areas that are there in the chain, be it in terms of thinking, perceiving, learning, problem solving, and decision making. So the kind of products that we have, the kind of solutions that we have, are able to impact businesses in each of these domains. So we started off as an IT solutions and business process management company. And over a period of time, we also strengthened ourselves in transport and engineering services, the entire logistics piece, big data analytics, and we have our own products, for example, True BI, then we have got True AI, True Cap, True Bot. These are all proprietary products which we have developed to help enterprises. Now, this topic, when AI meets human intelligence. So there is an interesting forum that I was a part of a year back. So that was the India Economic Forum. And we had speakers like Arundhati Bhattacharya, Arun Jaitley at that point in time, and then Piyush Goyal. So basically luminaries from the political industry, all these wakes of life. And there was another interesting speaker, and she was Sophia the humanoid who has also been given citizenship by now. So Sophia was a speaker, and of course, with a lot of interest, I was listening to her, and we were all marveling at the strides that technology has made. But my curiosity goaded me to go on to the Hanson Robotics page, her creators page, and what I found there was a very interesting mix of the AI and the HI part, which kind of, gave me the topic for my session today. So I will just read it out for you. So Sophia says that my robotics and AI accomplishments incorporate discoveries from many previous robots from this team, including the AAAI award-winning Philip K. Dick, and all this AI is networked into a whole using a protocol the Hanson AI team calls the Synthetic Organism Unifying Language, SOUL, S-O-U-L, SOUL. Recently, my scientists tested my software using the Tononify measurement of consciousness and found that I may even have a rudimentary form of consciousness, depending on the data I'm processing and the situation I'm interacting in. So all this AI is wonderful. However, it's important to know that no AI is nearly as smart as a human, not even mine. Therefore, many of my thoughts are actually built with a little help from my human friends. So this sums up this collaboration between human and artificial elements so well. So there are times when I get to hear from the talent pool that we have all across the globe, that and in different conferences that I go for. So is AI here to take away jobs? So should we be afraid of AI because things are happening at a breakneck speed? So that's where I say that it's not an either or, it's an and. AI is an enabler. So whatever we are doing today, we can take that notches up if we are able to tap the potential of artificial intelligence. And the reason also, I'll tell you, see, Professor Wilson of University of Virginia had mentioned this in one of his research reports, that at any given point, at a second, our brain is being bombarded with 11 million pieces of information. That's huge, huge information, right? And our brain is only able to process 40 of these, not more. So what happens in such a situation? In such a situation, there are a lot of implicit biased decisions that might happen, right? Implicit biased decisions which have now which are now known to be as unconscious biased decisions, right? Because as human beings, as conscientious human beings, of course we will remove bias if we can help it, but there is so much of it which is unconscious, which is there in our being, which is influenced by the inherent diversity in us, our religion, our culture, the places that we belong to, our habits, our interests, aspirations, all of that make up what we are today. And hence there is bias which is automatically bound to creep in. So keeping all these things in mind, when Datamatics started off this journey, that was quite some time back, but over a period of time, we have also upped our game. We have launched multiple versions over a period of time, each one more effective than the other. So our product, TrueBot 4, our robotic automation, robotic process automation product, which has the features of artificial intelligence embedded in it, has some of the very, very key features in the latest version. So we have all these AI capabilities built into it. We have integrated intelligent document capture. We have got a proactive bot health monitoring, a dynamic bot station selection, whole lot of it. And incidentally, we also, during COVID times, we had an enterprise deal, enterprise solution, and we put up this product for free for all our customers. In fact, since all of you are in this field, in case you have that interest, please visit Datamatics website and you can still see that link for free usage of our RPA product. And that's something which can be quite useful to different enterprises. Now, when it comes to decision making, etc., it's not always a very easy thing, because when you talk about bias, automatically certain aspects come into it. There is an aspect of ethics, there is an aspect of privacy. So perhaps you have heard in this conclave before. So there is a FAT framework, FAT, fairness, accountability, and transparency. So all of us who are in this space where we put forward AI provided solutions and products, we have to keep in mind that we pass that benchmark of the FAT framework. And why is that important? Because AI is able to touch the experience at a human and human level, actually at multiple levels, right from a compliance to efficiency to enablement to experience to empathy. It can be touched at every level. So this is something that we have picked up from one of the reports that was there in Oracle. So it was Oracle's HR digitization maturity model, and it spoke about these 5 different steps. So digitization, automation, putting in artificial intelligence elements to improve efficiency and effectiveness, these are all linked somewhere. They're all a part of our digital journey. They're all enabling us to be on that digital journey, which was always important, but probably COVID has forced us into this journey within a very short span of time. So as they say, that who has been leading the digital journey in different organizations? It's not chief digital officers, it's COVID instead. So the genesis has been much before, So if you remember, if any of you would remember 1968, so there was this magnum opus, Space Odyssey, and HAL 9000 was the supercomputer, the computer which was antagonist. And in 1968, when a computer posed as an antagonist, it was quite a shocking thing for people to digest. 50 years later, IBM came up with IBM Watson minus the evil tendencies. So I have been fortunate enough to be a part of organizations like IBM, Sony in the past, which have continuously been on the innovation path. But there is one aspect which has been kind of constant, which is how do we traverse that journey between compliance to empathy. So AI has been helping there, and some of the experiences, some of the instances that I shared, the cases that I shared will help put this point across. So our TrueBot product has enhanced the customer experience for a bank. So as you know, bank has multiple service request emails, right? And not all of those emails would have the same priority. So when human beings does this, then the processing of service requests can be very, very high, right? It can take a lot of time. So that's this bank had implemented TrueBot Neuro, our artificial intelligence-based solution. It's a large multinational retail bank, and the speed of processing service requests came down from 4 days to less than 1 day. So yes, it is a compliance requirement, and it is also an efficiency requirement. It's also an experience requirement, right? Because imagine those days when it used to take so long to open an account from the time that it takes now. So obviously the experience has increased many-fold. My second example, TrueAI, our artificial intelligence product, which has helped optimize sales for a multinational consumer products giant. So what we did here was we wanted to see how across different brands, the price varies. And based on those variations, can we check how the future price trends can be? So keeping a check on the future price trends and the variations, the consumer products giant was actually able to increase its sales figures from 20% to 32%. Yeah? So depending on the price variations, they could do the different product promotions. They could also use the predictive analytics solutions, and all of it ultimately helped them to boost their sales. Again, this is more in a compliance aspect. So TrueAI can detect frauds in real time. Yeah, so it has that ability. And as you know, there are the instances of frauds is something which plagues the financial services sector. The fintech companies are very much into it, and of course, any industry for that matter would be having issues about frauds in the financial interfaces. So our solution was able to identify the high-risk accounts which could be monitored, their transactions could be monitored, and scan for anomalies in the data and identify those transactions which could be potentially fraudulent. So a solution like this in the financial services sector, probably there are quite a few of you here from that sector, can actually work wonders, and it can actually take out a lot of inefficiencies from the process as well. Moving on to the travel and tourism industry, right? So when it comes to predicting customer conversion, see, we keep checking a whole lot of websites for travel, tourism, when we have made a decision to go for a travel, and when we have not made a decision, right? But how does the travel company know how it will be able to convert these customers, the different patterns, choices, etc.? So our solution helped to manage that data in a very efficient way, and an analysis of the past conversion patterns gave them very good insights, which actually helped them to create something which is an impact relationship framework as to what are the drivers of customer conversion, right? So if you imagine how things were in the 10 years, 15 years, 20 years back, travel industry was still there. But in terms of understanding the customer trends and getting all those insights at the click of a button, this was unthinkable. Travel has gone up so much since then. Travel experience has become so much smoother. And have you also realized something? We keep seeing that we do some search in Google, right? And it could be about a movie, about fashion, about a travel location, whatever it is. We find those linkages coming up in our Facebook when we open a Google page for another search, that hey, you could be interested in these things. How does that happen? So of course we know that there is this entire algorithm at the back which is kind of creating all these linkages and has made the experience much smoother, along with a wow factor, of course. Moving on to broadcasting company. So we have used, they have used True AI, and they have been able to derive a viewership pattern. Now, media industry, of course, the viewership pattern is the most important thing over there. And it's an industry where the report card is kind of out every week, right? So we had, I remember in Sony, we had the TAM ratings coming up every week. And as business, we would wait eagerly as to where does Sony rank for that particular week in terms of viewership. Is Star ahead? Is Z ahead? Are we ahead? All of those, right? So for the media industry to be able to derive viewership patterns and actionable insights is a very important thing. And the impact of it, we could achieve model accuracy up to the level of 85%. So it was quite complicated, of course. So it took into account the customer demographics, the different channel playout data, all of it, a lot of reconciliation processes followed. But ultimately, it improved the efficiency of the sales force, right? If you know the viewership pattern, automatically that translates to the kind of products that you can position in those particular shows where viewership is high. And end of the day, we had a very high model. We had the model accuracy was improved, and of course, we had improved average revenue per lead, which was very beneficial to the company. Web scraping, intelligent web scraping. So True AI has been helping organizations to web scrape data sources, which could be very useful. And this data scrape is saved on demand. It can be scheduled to run at desired frequency. So overall, it could actually reduce the TAT for processing an action from 20 minutes per magazine to 2 seconds per magazine. Of course, this also reduces manpower. This reduces OPEX by 50%. There were a whole lot of benefits that could be arrived out of it. And what do we do with the extra money, with the manpower that gets reduced? So, like I mentioned initially, so we can have our manpower, we can have our staff think of more and more of these innovative solutions, which can actually add a lot of value in the long run. So basically, it's freeing people, it's freeing professionals of a lot of non-value adding tasks, and actually providing people the bandwidth to go for things which have a far more strategic impact. Of course, when it comes to our function, the HR function, there are issues that are there because HR tasks are very complex, right? In order to explain the writer of the algorithm about the complexities, that in itself is a task. Too much of AI can lead to lack of human touch. Availability of appropriate data can lead to issues, but over a period of time, HR has been able to tackle those issues, and we have a very high AI impact on HR today. So it varies from organization to organization, not that all organizations have gone into this journey in a full-fledged way, but some of the benefits that I can talk about, of course, there's a lot of personalization, right? So we are aware of the learning patterns of individuals. So I don't need to go through a whole host of programs which have been offered to me. AI helps me to actually match my needs with the programs that are on offer. So the experience is far more personalized when it comes to the different kinds of workflows we have, be it interview scheduling, performance feedback, discussions, etc. That entire automation can happen through AI. I'll come to recruitment last. Better prediction models, of course. So predictive analytics has actually helped us to figure out how the turnover rates could be. Where do we have those pockets of stability, and where do we have those pockets of instability where we can expect people to move out soon? And that insight actually helps us to think of strategies as to how we can tackle that problem. And probably one of the areas in people interface where we are seeing maximum work happening today is recruitment. So there are chatbots which are improving processes. There is CV parsing that is happening out of so many different CVs, which are the ones that we actually need. So those are being pulled out by the use of AI, which is definitely very useful. There are recommendations even for learning development. Like I said, the chatbots can help in policy and benefits information. Even for candidate engagement, we can use that. So you can see the percentages. So almost 50% of usage, is there for most of these areas. So AI is an enabler, not a doer. So doer, of course, we will still have our staff, our workforce, which will use their intelligence continuously to ensure how we can leverage AI better. So here we look at some of the recruitment, some of the impacts of AI in recruitment. And one particular area I will pick up, I know there isn't much of time. We are 4 minutes away from 4:30. So reducing bias. And, being a researcher, I think the research instances comes to my mind almost always. So there was this famous study undertaken, which got covered in Harvard Business Review. So that was Heidi and Howard. So there was a CV which was given to two sets of people. To one set of people, it was told that this is the CV of Howard. So Howard as a guy is someone. So both of them actually, Heidi and Howard, they are from the financial services sector, very sharp individuals and good track record. So when people were given the CV of Howard, they felt that here is a guy who's a go-getter, who's very, very sharp, focused. People would love to work with him, target-oriented, achievement-oriented, result-oriented. The same CV, only the name Howard changed to Heidi. When that was given to people, they felt that, the person seems to be too pushy, could be too aggressive. People may not enjoy working with this individual. Somewhere the human touch could be absent in the dealings of this particular person. So just imagine just the change of a name and how much of a difference it creates in the minds of people who see the CV when it comes to perception about the individual. Right? So these are the different unconscious biases which are kind of embedded in minds. And when we use artificial intelligence in the recruitment process, we are able to remove a whole lot of these actually. So this is a famous case, and I tend to use it always for the artificial intelligence sessions because it makes the difference very clear. And of course, there are other areas also where we use AI, the virtual assistants, predictive analytics I've spoken, the personalized learning. We have also used that to understand how employee engagement has been, the percentages of actively engaged, disengaged employees that we have. We also have done sentiment analysis of employees through the different kinds of feedback that we have received in our climate survey, the internal survey, and that has been immensely helpful to understand where we are headed, and we could accordingly decide our people strategy, based on this feedback, because we knew that it was unbiased. So this is what I had to share within a short span. Over to you all for questions.
Thank you, ma'am. Thank you so much for your presentation. If there are any questions, audience members are requested to post them in the chat box, because the forum is open for questions now. Ma'am, we will wait for some time for the audience members to.
And I think you have introduced me already. If anybody wants to connect with me on LinkedIn later for any of the questions emerging out of this session, I'll be happy to respond.
Sure, ma'am. Ma'am, I have a question while we wait for the audience members to come up with something.
Yes, please.
Automation is going to impact a lot of industries, and even Elon Musk thinks that robots will be able to do everything better than us. So from HR perspective, are there any niche human activities that can never be automated or are at lower risk of automation?
I think it's a very thoughtful question, I would say. We have just now mentioned that almost every HR life cycle can be impacted by AI or automation. What cannot be impacted ever, or what cannot be touched ever, is the human touch. So we are all human beings, and we all have that inherent need to feel engaged, to feel loved, to be in the comfort of a society. So no matter how much of machinization we do, that aspect can never be taken away. So we can have chatbots which answer questions related to the policy. But when it comes to an employee who's in two minds, that policy tells me something, should I do this or should I do that? Who's that advisor, that HR advisor, that consultant who guides him or her about career choice? Should I quit? Should I not? So for all these decision points, it has to be a conversation, and that can always be led by a human being.
Thank you so much, ma'am. Thank you for the answer. We have one more question from our Honorable Vice Chancellor, sir. How much HR policies are being determined through AI at the moment?
Okay, so sir, right now I wouldn't say AI is determining any policy. AI, like I mentioned, has been an enabler in most cases. So learning and development does have a policy, so we know what kind of training programs we are going to offer to what kinds of employees. So there is no policy of AI which will guide this, but AI will definitely make it easier because it will understand what kind of training needs the person has had traditionally. So before we can check out, AI would be able to tell us that when it comes to functional needs, when it comes to behavioral needs, when it comes to technical needs, this is where the gaps are. And hence ABC kind of programs could be offered. So the role has not been in the policy determinant stage as of now. Probably in future that's how it could be. But as of now, it's an aid.
Great answer, ma'am. Thank you so much. And there's one more question by Mr. Wakara Naveen. Can AI in HR be considered one of the hardest problems in AI, or is it achievable very soon? I think he wants to know, is AI in HR very hard?
Yes, AI in HR could be quite tough. And sir, why I would call it tough, if you remember the FAT framework I spoke of, fairness, accountability, and transparency. At the end of the day, we are dealing with human emotions and human sentiments, right? And we also have to remember people who write these algorithms, the quality of those algorithms will always be influenced by the life experiences of the people who are writing those. So we can never ever eliminate a certain amount of bias even in those algorithms, right? So while I said it does help in unconscious, in removing unconscious bias, but there will always be an element which will be there. And we will never be able to replace the human aspect with AI, that is for sure. But how processes can be improved? Oh, there is a whole world of opportunities over there. But let me also share that as of now, there hasn't been much of a ROI which organizations have been able to establish. For example, why would someone give me the business of parsing through hundreds, thousands of CVs, millions of CVs? Can that be done by recruiters? Yes, AI can do it faster. That's also known. Probably AI can do a better job. But is there a huge business ROI in terms of dollar savings? Is it a huge amount? That linkage has not yet been established by the business to that extent. So that's probably some parts still left for us to cover.
Thank you, ma'am, for shedding this light. And now there is one more question from our Vice Chancellor, sir. You were talking about artificial intelligence in travel and tourism, and we have seen Alibaba's intelligent hotel about 3 to 4 years ago. So why is there no more development in the field of intelligent hotels heard ever since? I think the
Yeah,
inception was.
so yes. And just before I go to the Alibaba's example, I will also give an example of some work we did with an ocean engineering company. So obviously these are very niche areas, yeah. But one reason why be it Alibaba's portal or even with this particular industry sector, we have not seen much of advances because somewhere I think that ROI aspect has become very, very paramount. These days, people are so cost conscious. So for every dollar that you spend in a developmental activity for a business, if you're not extremely sure as to what the yield is going to be, you will not delve into it. It's not only about the cost, it's also about the bandwidth of the people. So I think over a period of time, we've become very conscious about the bandwidth usage, the money, and more we are going to see this trend that the maximum bang for the buck, it has to be justified. So the justification is yet to come in.
Thank you, ma'am. Thank you for such an interesting answer. Thank you, Dr. Ghosh Chaudhary, for delivering a very interesting and thought-provoking session. We were greatly honored to have you in this conference today, ma'am. Thank you so much.
Thank you so much, Shatabdi. I on and off, I keep getting into the conclave to see the proceedings when I have time. And you have been coordinating and hosting really well. Kudos to you and thank you to the organizers for inviting me here. Have a great day.
Thank you, ma'am. You too have a nice day. Finally, I would like to invite Professor Shomen Nayak, Assistant Professor in Department of Computer Science and Engineering, to deliver the vote of thanks. It's over to you, Professor Nayak.
Okay, ma'am, I'm audible to you? All?
Yes, sir, you're audible as well as visible.
Okay, fine. So, being a convener of this conference, I would like to spread my thanks to our Honorable Chancellor, sir, Vice Chancellor, sir, to our university, as well as the committee members of our conference named GCAIA2020. On behalf of the entire team of this conference, I am very hearty gratitude to all the speakers for sharing their graceful or valuable knowledge with us via this conference. It has been our tribute to all the members, audiences, to make this conference a grand success. I'm very much thankful to all the participants for participating in this conference by submitting good quality research papers. We have been fortunate to have of the renowned identity from the academic, industries, and other areas. I am very sure that our university, named University of Engineering and Management Jaipur, will continue to get significant provision from the diverse group in future. I want to extend my generous thanks to the entire attendees, participants for participating from different parts of the world in this difficult situation of pandemic. I'm really thankful to all our professors for their leading supervision and inspiring every moment of time in our university. With this statement, I want to conclude my vote of thanks session. Thank you all and have a nice day.
Thank you, Professor Nayak, for the vote of thanks. The great American author Kurt Vonnegut once said, "The emptiest and yet the fullest of all human messages is goodbye." With this, we reach the end of Global Conference on Artificial Intelligence and Applications, GCAIA 2020. My thanks to all the delegates and audience members for their presence and contribution in making this conference a grand success. Thank you all and have a nice day.
I wholeheartedly thank Professor Shomen Nayak for organizing this conference, and also I wholeheartedly thank Professor Shatabdi Basu for anchoring this conference throughout these 3 days. It was a mammoth job done by both of you. Thank you, and also the placement team for organizing with the industry leaders and bringing them on this platform. And thanks to all the professors and the students who attended. Thank you so much.
Thank you, sir.
Thank you, sir. Thank you for your kind words.